4, 3, 2, 1. Guys, I want to be very clear. There is not one way to do this problem. There's actually two ways. You should have taken AQ and filled in your diagram with 21. Are we Gucci there? Any discrepancy on where AQ lies on the diagram? Now, AQ is part of a median because it says that Q is the centroid. Where the centroid is all the medians. Now, the centroid divides that median into two parts. What portion is AQ of the whole thing? It's a third. So we're going to write AQ is equal to 1/3. What is the whole median? Okay, it's going to be 3/3, right? It's going to be the full length. But what segment represents the entire thing? AL. Do you guys agree with that statement? Because AQ is the smaller of the two pieces, so it has to be 1/3 of the full length, which is AL. Now, we know which length? AQ. So we're going to go ahead and substitute in what for AQ? 21 equals 1/3 times AL. Guys, this is a standard algebra problem now. How do you solve for AL? Multiply both sides by 3. Why? Why do we multiply both sides by 3? Juliet? Because what? Very good. What do we call it when we flip a fraction? It's the reciprocal. You always multiply by the reciprocal, and we get 3 times 21, which is 62, which is AC. Okay, so if we know the full length, it's 63, and it's also AL, right? Dang. Okay. So it should be 63, and it should be AL here. AL and 63. Okay. How do we find, if we know that AL is now 63, how do we find QL? German. Good. QL is going to be 63 minus 21. Because if you take away this piece, do you guys agree that we're looking at QL now? And that would be what? German. 42. Okay? I said there were two ways to do this problem, correct? Bear with me here. If AQ is 21, remember, AQ is exactly half of what length? QL. So we can take 21, multiply it by 2, you get 42 over here, and then you can add those two together and get 63. If you're not a proportions person and you get confused by that, then do this portion, okay? Set it up with 1/3 of the full length is going to be AQ, and then go from there, okay? But if you are like, you understand the 1/3, the 2/3, the full thing, then do it that way. Yes?
You have also just done 21 times 2, and then 40, whatever you got, plus 21.
Yep, absolutely. So that's how I did it here. I did 21 times 2, I got 42. So I knew this length had to be 42, and then you could add them both together and get 63. Any questions on the warm-up? So today we're talking about something called a mid-segment, okay? Now, it's in the word. It's a segment that connects the middle of each side. That's why it says mid, okay? So in other words, there's going to be a point that's very important in this lesson. What do you think that point is? The midpoint, okay? So that's just a helpful little trick to remind you what a mid-segment is. It involves the midpoint of each of the sides, okay? So specifically, by definition, the mid-segment is a segment that connects the midpoints of two sides of the triangle. Every triangle has 3, which form the mid-segment triangle, right? Because each side of a triangle has a midpoint. And when you connect them, you form the mid-segment triangle. So our original triangle, bless you, is ABC. What are the coordinates of the mid-segment triangle in this example? Christian? Very good. So we're going to write that the triangle PMN is the midsegment triangle. I'll give you guys a second to copy this down. Okay. How do you know that M is a midpoint? Gio? It's in between A and B. Very good. But how do you know it's a midpoint and not just the point in between them? Yeah? Very good. Do you see the two congruence marks on AM and BM? If those two pieces are equivalent, do you guys agree that M has to be the midpoint? And the same thing happens for P. Do you guys agree? P is the midpoint of what side? BC. And N is the midpoint of what side? AC. Now, I want you guys to pay attention, okay? If we're connecting all the midpoints of the triangle, right? PMN is the exact same shape as the larger triangle. Do you guys agree? But it's actually related by a fraction, right? How much larger do you think the black triangle is in comparison to the red one? Think about the points that we used, yeah?
3/4.
Not 3/4.
2/3.
Not 2/3. Think about what a midpoint is. Midpoint is what portion of the whole thing? Half. So how big is the red triangle compared to the black one? It's half of it, okay? So this small triangle is a half of the whole thing, okay? I want you to relate midpoint, okay, to being half, right? Now, the red triangle, I said the red triangle is exactly the same shape as the black one, correct? But it's like inverted. Do you guys see how it's kind of flipped upside down? So the similar point to point B is which point in the red triangle? N. Do you guys see that? And the similar point to A in the red triangle is what? P. And the similar point to C is M. Now the cool part is exactly half. So each of the sides of the red triangle are exactly half one of the sides of the black triangle. Yes, Kristen? Oh, yes, you can. All right, now they take this and they run with it into a theorem, okay? And the theorem says that the segment connecting the midpoints of two sides of a triangle has two things. It's parallel to the third side, and it's also half as long as that side. So if DE is a midsegment because it connects two midpoints, then DE and AC have to be parallel, and DE is exactly 1/2 the length of AC. So there's two properties that you get by dropping the midsegment theorem. It's parallel to a side, and it's exactly half the length of that side. So if I told you that AC was 10 units, what would be the length of DE? 5. You divide it by 2. If I told you DE was 10 units, what would be the length of AC? 20. Do you guys see how that works? Okay. Are there any questions on the midsegment theorem? Okay, let's try to apply it. Triangles are used for strength in roof trusses. In the diagram, UV and WV are midsegments of SRT. So right then and there, I know that those two are midsegments, so let's go ahead and start filling in our diagram. They're talking about RST, so I'm just going to bold it in a different color so I can visibly see it. RST is our full triangle. And our two midsegments, I'll put them again in blue, were UV and VW. So U, V, and W must be what kind of points if those are mid-segments? What's so important about U, V, and W? How do you form a mid-segment, guys? With midpoints. So that means that U, V, and W are all midpoints. So let's label them. Put MP for midpoint, MP, and MP. So each of those three are midpoints of the sides. Do you guys agree? Now, if they're midpoints, what segments can I now put congruence marks on? If those are midpoints, what segments can I put congruence marks on? Daniel, give me one pair.
RW.
RW is going to be congruent to what?
UV.
Eventually, yes. I agree with you. But let's start with RW.
WT.
WT, very good. Because W is the midpoint. Do you guys agree? So if it's the midpoint, do you agree it cuts this side in half? Perfect. Okay? What else would have to be congruent? Alexis?
SV,
SV would be congruent to?
VT.
VT, very good. So 2 congruence marks there. Who can give me the last pair? Go ahead, Elias. Perfect. SU and UR. Any questions on that? Filling in that part of the diagram. Okay, now a mid-segment, right? It has to be parallel to one of the sides of the triangle, right? So let's take a look at UV. Which side does UV appear to be parallel to? RT, right? So put parallel markings on those. And now watch what I'm going to do. RT is exactly double UV, correct? So I can put a congruence mark here as well. Let's think about why I can do that. RT was cut in half by W. Do you guys agree? So RW is exactly half of the full length of the side. Do you guys agree with that? And exactly half of the full length of the side is also the mid-segment. Do you guys agree?
Sure.
So all 3 of those pieces have to be the same length. Now, what is their length if the length of RT is 90 inches? Nick?
45.
They're each 45 inches. Okay? Now, part of our problem, it asked us to find UV. And we just found UV, okay? UV was 45 inches.
Where'd you get 45?
Where did I get 45 from? I took this 90 and I did what with it? Divided it by 2. Because remember, this length of this full side has to be half, right? Half of that length is going to be UV. Does that make sense? Yeah, Gio? Why I put the parallel signs? That came from the last theorem that we just talked about. Because it said that that was a mid-segment, it has to be parallel to one of the sides and half the length of one of my sides. Okay? Any other questions on that piece? Okay. What was the other mid-segment? Which side? VW. So VW has to be parallel to one of the sides of your triangle. Which side of the triangle is VW parallel to? Cody? UR, or I would say SR because that's the full length of the side, right? So very good. It's going to be parallel to that side. So do you guys agree I can say that VW will be the same length as those other 2 pieces? The second part of this problem was asking us to find SR. How would SR relate to VW? Jaden? It's twice the size of VW. Very good. So SR is going to be 2 times whatever VW was. And we know that VW is 57. So if we take 57 and we multiply it by 2, that'll give us SR. So SR equals 114. What were the units? Inches. And this is not part of the problem, but can anyone tell me what the last mid-segment would be? UW, very good. Okay. Any questions on this example? Go ahead, Cody. The last mid-segment would be if we were to connect U and W, okay? But it wasn't on our diagram, okay? All right, guys. We're going to fill in this entire chart, but you have to take it one piece at a time. So I want you to circle. A is going to involve all of these lengths. Oops. B is going to involve like a second piece, so treat B as a completely separate problem. And then C, same thing, treat C as a completely different problem, okay? We're going to take it one piece at a time. So if we're looking at letter A, we're given all three of the lengths of that large triangle, and we're asked to find each of the lengths of the mid-segment, okay? So let's start with AB. If AB is 12, so if this length is 12, what length do I now know in the mid-segment? Which mid-segment do I know? Yep. It's not ST. It's RT. Because if you know this segment, right, that side is parallel to which side in the mid-segment? RT. Do you see that? So that's how those two have the relationship. So RT is going to be what portion of AB? Half of it. So what's 1/2 of 12? It's 6. So I know that RT has to be 6. All right. And if I know that BC, this length down here, is 14, which length of the mid-segments do I know? Sophia? I do. It's RS. RS is going to be what? 7, because those two are parallel to each other. It's exactly half. So you take 14, you divide it by 2, and you get 7. So RS would be 7. What about ST? How would we find ST? Daniel?
Divide AC by 2.
Divide AC by 2. And AC was 18, so what does our ST have to be? 9. Questions on that one? Letter A. Okay, moving on to letter B. Guys, how would you find out AB in letter B? You can erase, if you need to erase on your diagram, you can erase each time. How would you find AB in letter B? Cody? RT is 10. How does that help us? Good. RT is exactly half of AB. So what do we do with RT's value? You add 10 or you multiply it by 2, right, Cody? So what's the length of AB? 20. Okay. How do we find ST? How do we find ST? Zach?
Divide AC in that.
You divide AC by 2. So what is ST's length?
11.
11. Okay. We take 22, we divide it by 2, and that gives us the 11. And what about RS? How do we find RS? Daniel?
Divide BC by 2.
Good. Divide BC by 2. So we take 15 divided by 2. What does that give you? 7.5. Okay. Letter C. We've got AB is 10. BC we don't know. AC we don't know. We know ST and we know RS. How could we find BC? How could we find BC? Daniel? Good, multiply RS by 2. So if you take 7.8, multiply by 2, what do I get? 15.6. What about AC? Someone new. Nick? Multiply ST by 2. And ST was 9, so AC has to be 18. And the last one, RT. Kristen, go for it. It would be 20? Ah. Remember, AB is the larger or the smaller piece? Ah, it's the larger one. So if it's 10, instead of multiplying by 2, what do? Divide by 2. So it should be 5. RT is going to be 5. How are we feeling? Any questions? Guys, in your discussions, did anyone have anything helpful? Like, did anyone say it a way that really resonated with someone? Great. Do we have questions after we've gone over it? Okay, let's do a tougher example that involves X, okay? All right, so it says that ABC are the midpoints of the sides for the triangle GH and J. So we know that they're midsegments, okay? AB is a midsegment, BC is a midsegment, and AC must be a midsegment. If GH is 7x minus 1 and BC is 4x minus 3, what is GH? Let's fill that in, guys. So go to your diagram and fill in GH and fill in BC. What did it say GH was? 7x minus 1. And BC? 4x minus 3. How are they related? How are they related? German? Very good. BC is going to be exactly half of GH. Now, for those of you that don't like fractions as much as I don't like fractions, how can we change this so we no longer have a fraction? Daniel?
Multiply BC by 2.
Good. Multiply both sides by 2. So, do you guys agree that 2 times BC is also the equivalent of GH? You guys cool with that? So, if we're given a midsegment, you could just multiply it by 2 and you'll get the length of the whole thing. So watch, I prefer to use this relationship because now I'm not going to have fractions when I distribute, okay? So we're going to take the expressions for x and we're going to substitute them into this equation. So take BC, substitute it here, and take GH and substitute it here. What's my new equation after I substitute? What's my new equation? Nick? 7x minus 1. Are there any questions on how I got that? We're good? Okay, Amanda, what would you do with this equation? Excellent. What do you get? 8x. Then what?
Then you distribute it to 3.
Positive or negative 6? Negative 6 equals 7x minus 1. Okay, Mario, what would you do after that? Add 1 to both sides? Sure. What do you get? Okay. Sophia R., what would you do after that? What do you get? Negative x and negative 5 over here. What's my last step, Cody? Yay! GH is equal to 5? No. What did I forget? Plug it back in. Gabby George, when I plug it back in, where should I plug it back into? Either one? No. They're not the same length. Which one was it asking me for?
London, Phoenix.
GH. What was GH?
London, Phoenix. Report student service.
7x minus 1. So take this 5, plug it into this one, and we're going to get GH equals 35 minus 1, which is 34. Now, let's say we plugged it into BC. We would get what if we plugged it into BC? Yep. 17. What could we do with the 17 to figure out GH? Multiply it by 2. So do you guys see how those two are related? Yeah. Dougie?
Could you also just plug it into the 8x minus 6?
8x minus 6? Yeah, you could. Did you guys see that? So remember how GH was 2 times BC? You could plug it in here, and it would still give you what BC was, because BC was 7x minus 1. Any other questions? Okay. You're only going to get through a portion of the last example, okay? But we will have to save the rest of it for Monday, okay? All I want us to do is to be able to prove that DE is parallel to AC, okay? So, underline the fact that we need to prove that they're parallel, and let's write how we would prove that they're parallel. What does parallel mean in terms of a graph? Oh, what about the slopes? They're the same. So we have to prove that they have the same slope. How do you find slope when you're given a graph? How do you find slope when you're given a graph? Yep. Rise over run, baby. Okay, write it down. So we're going to do rise over run for both DE and AC. Let's do it for DE first. So we're going to do the slope of DE. Start at D. How much do you rise to go to E? 1, 2, 3. So plus 3. Why is it positive? You're going up. And then to get to E, you go how many units to the right? So plus 2. Why is it positive? You go to the right, okay? So what's my slope? Is it 2 over 3 or 3 over 2? 3 over 2. Why is it 3 over 2? Rise over run, okay? Watch what happens when we calculate the slope of AC. You're going to rise how many? Plus 6. And run how many? Plus 4. Guys, it doesn't match. Does it? Why does it match?
You can divide 6 over 4 by 2.
Simplify 6 over 4, it becomes 3 over 2. This is where we're stopping. We just proved that they're parallel. Turn these in.
Okay, so as soon as we prove that the slopes are the same, then the only thing that we have left is we have to prove that the segment DE is exactly half the segment of AC. So how we're going to do that is we're just going to find the length of DE and the length of AC. So DE, let's find the coordinates of it. It's located at 0, -1, and E is located at 2, 2. Okay? So when we're finding the distance between D and E, we're going to write DE equals, we'd have to use the distance formula because it is on a coordinate plane and it is a slanted line. So we cannot just count the units. So we're going to use the square root of the x2 value, which let's just go ahead and label. It'll be x2 and y2 over here. And we'll make x1 and y1 over here, the D. D will be x1 and y1, and E will be x2 and y2. We're going to take the x2 value, which is 2, subtract the x1 value, which is 0, and then we're squaring it. Then we're adding y2, which is 2, minus the y1 value, which is -1, and then we're also squaring it. So we're going to end up getting DE equals the square root of 2 minus 0 is just 2 squared, plus 2 minus -1 is 3, and then we're squaring it. So we have DE equals the square root of 4 plus 9, which gives me the square root of 13. That does not simplify, so we're just going to leave it. All right, and then let's do the same thing, but let's do it for AC. AC is equal to the square root. I'll make A my x1 and my y1, and then C will be my x2 and my y2. So then I do x2, which is 5, minus x1, which is 1 squared, plus y2, which is 0, minus y1, which is negative 6. And then we're squaring it. So AC is going to be the square root. 5 minus 1 is 4. When you square it, you get 16. 0 minus negative 6 is going to be plus 0 plus 6, which is 6. When you square it, you get 36. So we have 16 plus 36, which gives me the square root of 52. Now the square root of 52, you can break that down into the square root of 4 and the square root of 17. Excuse me, not 17, 13. Because 4 times 13 gives you 52. So now the reason I pulled out a 4 is because 4 is a perfect square. So now this will simplify to 2 times the square root of 13. So as you can see, right, if we plugged it back into that formula, DE equals 1/2 EC, DE equals 1/2 AC, we found that DE was the square root of 13, and we found that AC was 2 times the square root of 13. This 2 multiplied by 1/2, they're going to cancel and give you 1. So it's going to be the square root of 13 equals the square root of 13, okay, which is true. So we just proved the mid-segment theorem, which says that if all your mid-segments have exactly the same slope as one of the sides, meaning that they're parallel, and they are exactly the mid-segment is exactly half the length of that parallel side, which we just proved. And then this last slide is just a breakdown of what we were doing and some questions you can ask yourself as we go along the way. How can you find the coordinates of D and E? Both of them are midpoints, so you would find the midpoint of the sides. And then how will you show that the midsegment is parallel to OC? You had to find the slope of each segment. And once we did that, we proved that they were equal to each other. And how will you show that DE is 1/2 of OC? We showed that by using the distance formula. That's it, guys.